REST APIs in the context of single-page applications. So we'll kind of transcend just a Ruby side because it's right on the edge of front-end, back-end. So I'll talk about some JavaScript as well. So by myself, I'm CTO of History. So we're a education technology startup. We did NESUP last year in spring. And so we're based in Mont-Saint-Hubert, but in February we moved to Boston. So we've been there ever since. Although because of visa issues, I have to come back every 3 months for a while, so that's why I'm here. I also organize of the Belgium Ember.js meetups. So if you're interested in Ember, please feel free to come. We did it in Brussels, and we did last week in Leuven as well, so we kind of alternate between the two cities. We're open to do in Antwerp one time with people here. So a bit of background. So the application is HTML5 web application. So the purpose is that it works on all devices, desktop, laptop, and tablets. So we have a Ruby on Rails REST API in the backend, and then an Ember.js frontend. So basically all the HTML, all the templates are generated on the client side. So the only communication between client and server is through JSON. And also one thing is our API is not public. So right now there's only one front end. But in future we see that we can make a public API like Twitter does or Facebook does. Okay, so I'm talking about quickly go over what is REST. Then I'm going to talk about authentication, authorization, use of HTTP status codes, and finally the JSON API initiative. So what is REST? REST stands for Representational State Transfer. I think it's kind of a weird name for what it does. Anyways, it's like an architecture for the World Wide Web. So one thing that it characterizes is that it completely separates client and server. Secondly, it's completely stateless. So that means that the server does not keep any state in the API. The URL takes a very important role in REST API, in that every resource is uniquely identified by one URI, and it's the sole resource that's being identified through it. And when you use REST on top of HTTP, you have these mainly four HTTP verbs that add semantics to the operation that you do on the API. So GET request, it's never supposed to change anything that's in the API. POST requests used to create resources. Put and delete are respectively to update a resource and to delete one. So authentication is the first problem we're going to look at. So as I said before, REST is completely stateless. So that means that authentication implies state. So either logged in or not logged in. Clearly not logged in. So you have to store the state, authentication state somewhere on the client. One very common way to do that is through token-based authentication. So basically when the user logs in, the server generates a token, randomly generated. It returns that token in the response, and then the client to authenticate its request sends this token every time it does a request to the server. So quickly show how it works. So imagine you have like an endpoint API/login. You provide like an email address, credentials, and password. Server returns a token. And then with every request that the client does, it includes this token in the request. So how do you store that token on a client? One way is to just simply do it in memory. Since we're talking in the concept of single-page applications, it means there are no page refreshes. So as long as the user is normally using the application, you're like with the memory, the JavaScript memory you're using stays intact. The problem with this is that it does not persist when you close or open a new tab, and also when the user hits refresh, then memory is gone. So you lose your token. Second way is the way things have always been, kind of. is through cookies. So you store your token in a session cookie. This cookie is automatically sent with every request you do in the HTTP packet. The problem with cookies is that they store text. They don't store objects. You have these libraries that serializes JSON objects into cookies and then deserialize them. That's kind of cumbersome, and also it's not very RESTful. And since not too long, there's this new specification called web storage specification. And this provides basically two storages, session storage and local storage, which are secure and which are per domain. And with this you can store JavaScript objects that persist throughout sessions. So they remain on the client, they're not automatically sent like cookies with every request you do. And for that, you have to send a token through a query parameter to be able to give the token to the server. Browser support is pretty good. Just show you here. So right now it's like at roughly 90%. And then there are polyfills as well that create fallbacks back to cookies if local storage is not supported. I think it's IE7, maybe IE8. Okay, yeah. So it's very important that all this requires HTTPS because you send the token through query parameter. Obviously, you don't want everyone to be able to read that token. So how do you do this in this case, Rails in device? Unfortunately, since 3.1.0, they deprecated token authentication. And as of, I think, 3.3.0, which was a couple months ago, they completely removed it. The reason is that the implementation that they had was vulnerable to timing attacks. So that's why they decided to remove it. But the maintainer of the project provided this little snippet of code which allows you to still use it in a secure way. So if you want to use it, just click on that link, which I will share later. Okay, so after authentication comes authorization. So the user is logged in, but then in authorization deal with permissions. So is user X allowed to perform action Y? So for that you need a kind of context-aware language that expresses enough to express this kind of permission. So for instance, you want to allow a user to modify its own profile, but you don't want to allow it to modify someone else's profile. You can enforce it in your front end, so you can make sure that through the logic of your front end that this never happens. It's probably working for 99.9% of the people. Then there's a smart guy who just tries it out, and then if he succeeds, then he can do basically whatever he wants. So what you want to do is define roles in your application. These are very specific to your specific application. So you have like admin, editor, user role, and then you specify permissions for each of those roles. There are a couple of libraries that have been developed for this. The one we use is called declarative authorization. Just here a quick example. So we define a guest role, which has some permissions, and then we define a student role, which includes guests, which means that all permissions, so everything that guest is allowed to do, the student is allowed to do as well. And then we have permission on timelines, this is actually code from our own application. So this basically says that a student is allowed to perform the show action on the timelines controller, if and only if the type of that timeline is user timeline, and if the student is the author of that timeline. That's what it expresses. Okay, then we move on to HTTP status codes. So they allow you to add semantics to your responses. So it's important to do that both for success, so like 200 and so on, and also the error status codes. So these are the typical responses that you get. So for a GET request, you reply with a 200 OK. For a post, so whenever you actually create a new resource in your backend, in your API, according to REST, you have to reply with 201 created. If you do a put and update, usually you don't reply with a response, but if you do, then you have to reply with 200 OK. And for delete, it makes sense not to reply with anything, because your resource is gone. So for error codes, there's quite a long list actually available. And it's not entirely clear, like, I think, like, there's no standard, like, protocol of how people do things. There are a couple of conventions, but they're not very clearly defined. And there's a lot of status codes, and sometimes it's kind of hard to find which one applies to your own situation. But these are like 4 main ones that we use. So 401 is when you have unauthorized access. So when you try to do something that for which you need to be logged in, but you're not logged in. 403 forbidden is if you have a permission error. 412 precondition failed is when one of the parameters in your query is missing. And basically we just throw a 422 in any other case if you have an error. So yeah, on Wikipedia there's a very nice overview of that list. Okay, then finally JSON API. So what's that? It's a new initiative by 2 people. One is Steve Klapnik, which is I think a big contributor to the Rails project. And the other guy is Yuda Katz, which is he does tons of stuff. He's like on the jQuery core team, the Rails core team, and he's one of the 2 creators of Emma.js. And so basically what they want to do with this initiative is to create a standard for the representation of your JSON responses. So the question is, how do you, when you have a resource, how do you represent it in JSON? And it comes from the belief that when you have these conventions, then instead of reinventing the wheel, you can use generalized tooling, which other people have made based on these conventions, to boost productivity. So it allows you to focus on your application logic rather than how to display, how to format your JSON responses. I'll quickly go to the website to show you. So it's kind of work in progress. So if you go to format, then basically it explains, it's very formal, it's a spec, so I guess it's a good thing. So basically it explains like how to represent different resources, what fields you can use, what response you should reply with. So let me just So this is an example of how a resource can be represented. The bottom part, I think it looks familiar if you have like the post, how to represent a resource. But then it also allows you to represent a resource based on its URL. So this can be handy when you have asynchronous, so not side-loaded relationships. So for instance, you have a relationship between like parent and child. You want to load the parents, but you don't want to load the child. But you want to say that, okay, if you need the child, then you can get it from this URL. Also specifies what status codes and location headers you're supposed to use. It also provides a convention for errors, which for myself, when we're designing the history API, I looked a lot like how do other companies do it, how do other APIs structure their errors, and they all do like something different. In the end, it's kind of hard to. So in the end, you try to, like, you have to pick a choice, and then you have to implement your own like error handling thing on the front end. So here, yeah, they provide a couple of fields which are now convention. Also provide a structure for the patch verb. So patch verb is it's not very popular yet. I think it's supported now on all the evergreen browsers. but not yet on, I think, IE9. And so basically it's another way of replacing a resource. So you provide operation, you provide the attribute, and then you provide a new value. So it's kind of a more performant way of doing a put request. And so, yeah, so the JSON API is a spec. And it's been implemented, well, the main two implementations are one side in Ruby, so there's the active model serializers gem, which was kind of dormant, it wasn't really much maintained, and so Steve Klabnik took it over, and they released the 0.9.0 last Friday. So the goal is really to make it compliant with the JSON API spec. And then on JavaScript side of things, front-end side of things, there's Ember Data, which is part of the Ember.js project. And they provide the JavaScript implementation of JSON API. But there are, like if you go on the website, you can see that for other languages they have them too. So I think Node.js has one, Python has one, PHP has one. So it's all in progress. And yeah, that's it. Any questions?
Maybe one. For your authentication, did you try using OAuth or something like that?
No, so the reason why not OAuth is that we don't have a public API yet. So I think OAuth has its benefits when you have several clients using your API, but if you, in this case, we just have one front end which is controlled by us. So it didn't make sense to use OAuth at that point in time.
For authorization, I don't know, why do you prefer, I forgot what the gem is called, instead of CanCan, for example?
Yeah, it looks like CanCan as well, but I found it's not expressive enough. I think I have difficulties expressing things like I expressed this in this example, where you rely on data in your model. That's, I mean, maybe a change in me. I think that's can as well.
Yeah, that's like the new version that's maintained because yeah, the previous guy.
Okay. Well, at the time I looked at can, it wasn't great. But there's one now called Pundit, which is very active now, and it's much nicer than declarative authorization actually. But it's a lot of time to refactors there. Any questions?
Maybe just some comment about registration of error codes. They are registered at INF.org, and the reference is folder RFC where the error codes are defined. So there is an official list of the error codes.
Okay, you mean the 4xx codes?
Yeah.
Yeah, but what I was pointing to is like how you structure your JSON.
Yeah.
Okay.
I just
Okay.
the code itself. There's a list of the things that are publicly recognized as official and stuff like that.
Yeah.
And how do you run kind of integration test over your API to be sure that how do you deal with that? Just
so
the common way of Rails, or do you something like just using wget?
No, so we use RSpec. So we unit test some models, and then all the serializers, stuff like that. And then there's extensive test suite for the controllers. And that's how the way we test the API. That's why the API starts or ends. And then when we go beyond that, we have a test suite in JavaScript and Ember framework, just to test the user interface. an integration of the API with the front end. Yeah. And so we test all these error codes, all the permissions, conditions. We test them in those controller tests.
If your responses get bigger and bigger, do you test at least once that the whole body looks exactly like you want to, or just partial data? Because we end up we implement something small and then you have to, it needs to be reflected with one giant test file with all outputs of JSONs that the response should look like, but it's how maintaining it, so...
Yeah, for that, I've got the same problem now, and what I do now is try to move from the control test to the serializers. So the serializer, like the active model serializers, that layer is supposed to take care of how the JSON looks. And so that's how I do it now. So it prevents having to go through the controllers.
Do you have already to deal with versioning?
Sorry?
To deal with versioning of your API?
Yeah, version.
Oh, versioning? No, luckily no. I'm dreading the time we have to. No, because I mean, we're the only consumers of the API, and so we're in full control.
Yeah.
So no one cares about the API except for us. But
Just internal.
yeah.
Any thoughts on caching? With the active model serializers, it used to be supported within the...
Yeah, I know they removed it. I don't think that they're going to do it, although they should. But I think now it's like the burden of the person who uses it.
Do you go low level yourself, or how?
Yeah, so we have like a Redis cache. So everything that has an ID, unique ID, is being cached Redis. And so when we get a request, we look at Redis first if it's cached and then send it. But yeah, I mean, it'll be easier if it's in active models. I'm not sure actually. Do you know why they removed it? Like what the
Just a comment that they said on GitHub was
removed?
something like that the way it was implemented was not robust or something.
Okay.
They said they had to rethink it, but that happened months
They've
ago.
been rethinking it for a long time.
Any thoughts on things like Rebel for generating the API? I have no idea if it fits the JSON API specs, but...
What's it called?
Rebel? R-A-B-L? Yeah, it's...
Oh, is it like a templating language?
Yeah, to generate the JSON outputs.
Yeah. I think I looked into something which uses Haml, or is it this maybe?
No, it's just, I'm not sure if it fits the JSON API specs, so it generates the...
I'm not sure by default if it does now. I mean, in the end, like it's a spec, so you can provide your own implementation of the JSON spec. That's on purpose.
Yeah.
But I'm not sure, like I don't know enough about it to say.
Cool. Thank you, Johan.
Thank you. Yeah, if you want, I'll put the slides on slideshow or something, and I'll post it on the...
And if you can share the comments, the slide on the meter.
Yeah, sure, I
That
will.
would be
Yeah.
great.
Cool.
Thanks. So next one is Xavier. Don't need to introduce him. I think everybody knows him. And he has a surprise talk. Didn't tell me what is it. I hope it's safe for work. So,
all right.
please.
So yeah, this is gonna be a short one. It's not especially very technical or anything, but I think it's the right moment to give this talk. So we're all Rubyist, I assume, And I think we realize, as the time goes by, that we need sometimes better solutions when we need to deal with a lot of concurrency and to write reliable concurrent software with no threading headaches and stuff like that. So there's a pretty new language that does that pretty well. So it's called Elixir. I don't know if you've heard about it. It's a modern, dynamic, functional language. It's created by someone you probably know, Joseph Alim, which is a pretty famous Rails contributor and device, etc., and a few other gems. And Elixir is inspired by Erlang for its concurrency model, a feature called pattern matching that we'll quickly see, and it's also fully compatible with Erlang libraries. There is no translation layer, no bridge. You can call Erlang code from Elixir and vice versa. And more importantly, it's inspired by Ruby for the syntax and the sort of joy of programming aspect of it. Because Erlang is not always a joy to program with. It feels really old. It's language from the 80s basically. And it's also inspired by Clojure for homoiconicity. So that means that the language, when you look at the code, you can actually think of it as data and transform data into code, and you have a very powerful metaprogramming system this way. And Elixir runs on top of the battle-tested Erlang VM. These guys have been working for 25 years on this thing, and Elixir just compiles to Erlang bytecode, and you can benefit from all this experience and all this very powerful runtime, which is really designed to run massively concurrent software in a distributed fashion. Elixir is not 1.0 yet, but it should be 1.0 by the end of the month. I think now it's stable. They're just fixing the last few bugs. So now is the right time to get started, maybe. Because in the previous month, sometimes things were not really stable and a lot of code had to be rewritten sometimes. So, but why would we want to do this? First, I think Elixir is pretty fun, just like Ruby. So I think many people just started playing with Ruby because it seemed like a fun language. And there is this growing importance of concurrent programming. And Ruby is not terribly good at it because of the implementation of the interpreter. And I think also learning to write code using immutable data structure, no matter the language, is a very interesting skill to get, because that's something you can sometimes apply into your Ruby code, and it's often a pretty good way to get more reliable software and software that's easier to test. And also the whole philosophy behind Erlang and Elixir is to design a distributed software using isolated processes, exchanging messages. In this case, process doesn't mean an operating system process. It's a very smaller unit of processing inside the Erlang VM. So inside a single Erlang VM on your laptop, you can run hundreds of thousands of processes. It's a very cheap resource. It's a lot cheaper than a thread. And the Erlang VM and its scheduler just takes care and gives the illusion that you're running these hundreds of thousands, if not millions of processes on your machine. So to show you just a tiny bit of code, I have a very simple example that I took from exorcism.io. I don't know if you're familiar with this website, where you can write code and have people reviewing your code. But they have this example of writing some code that deals with a bank account, and this bank account, each bank account in our system lives in a separate process. So it's a completely isolated computing unit, and the only way it talks with the outside world is through the exchange of messages. So let's say we want to open an account. We have this module called bank. We just have a function called open account, and this function spawn will create a new process in the Erlang VM, and the function running in this process will be this closure right here, where we start a bank account process starting with a balance of 0. So sensible default. So as you can see, the syntax is very close to Ruby. So what's this bank account process? This is where things become interesting. So it started with a balance of 0. And the first thing it will do is receive a message, or in this case, wait for the first message. This will be blocking. And this process, managing your bank account, will basically accept 3 types of messages. First one is a query for the balance. Second one is an update of the balance by some amount. And the last one is a message to close the account. So what happens if we want to ask for the balance of an account? We will send a message. The bank account process will receive this message, decode the actual payload of the message. The message has, in this case, two parts, a sender and an atom, just like in Ruby, symbol, identifying, in this case, the type of message. And we will simply reply to the sender using send. We receive a message, we send back a message. Hey sender, this message is coming from me. That's process ID of the bank account. And the request went okay, so we give some feedback to the caller, and here is my current balance. So, no, sorry. When we want to update, oh yeah, sorry, for something important. Once we do this, we need to keep the process running. So through recursion, we go back into our process without touching the balance in this case. So we go back there and we're ready to receive the next message. What if you want to update the balance of the account? We'll send a message from the sender, in this case, we're not really interested in because there will be no reply. A symbol to identify the type of message, update, and the amount we have to add on the bank account. So what we do here, we simply restart the process recursively with the updated state. And last message we can get is, oh, let's close this bank account, and in this case we do nothing. We do not go back to the start of the process will die. So it's a basic way of dealing with processes, and that's, I would say, the server side of things. This is for each bank account in the system would spin this process. So what if we want to make a deposit? So we can have this function, update account, we pass in the process ID of an account, the amount, and we use send to send this message as implemented by the server. This is a one-way operation in this case. What if we want to query the balance? First, we have to send a message asking to this account in this process, hey, yeah, this is me, I'm the client, please give me the current balance. So this is synchronous, so we need to wait for the answer in this case. So the client say, okay, I'm blocking now, and I'm expecting to receive a message from this account, and I will not go into the detail, but you need a little carrot in this case. And I'm only interested in messages that went okay. If the process didn't go well, then I don't care. I will just crash in this case. And this is the new balance, and the value, the actual value of the balance will be bound to this variable, and we just return this variable. So in this case, this is a synchronous call, but you could make it also asynchronous. I would say JavaScript style, by passing a function as a parameter, and the function will be called when the message is received, for instance. So we can see a few benefits to this very, very small piece of code. It's really boilerplate-free concurrent computing. There's nowhere any setup for thread pools, threads, synchronized memory, mutex, and all this stuff sort of just works. The messages are exchanged, each process has its own mailbox, it's blocking when it needs to block. That's pretty cool, and it's pretty much declarative. You can really see that all these features are built right into the language. It's not really some library you put into the language. The language is designed around all these ideas. And it's stateless in a sense that you can clearly see in this process that there's a complete separation between state and the actual process. The process loops just like any server, but there is no state mutation. We just call the same code each and every time with a new state. Nothing was mutated. It's always a new copy. Or in this case, it's always the balance that will be sort of increment. And there's this whole let it crash philosophy behind Erlang. As you can see here, the code is very simple because I focused on the happy path. And if anything goes wrong, it will crash. And well, when you build larger server, then you can set up, of course, strategies to restart things the way they should be restarted. But in this case, I think when I experimented with Elixir, I found this very interesting because you focus on the happy path, you run the code, you write one more test, it will just slowly crash, and then you can step by step add more support for newer messages, edge cases, and I think it's a very interesting iterative way to add features to little pieces of code. So why I'm talking about this? It's because I think now is the right time to learn Elixir. So we are starting an Elixir study group. This is not really officially like the Elixir user group or anything, because nobody really knows a lot about Elixir right now yet in Belgium, as far as I know. So we need to first get good at it. So what we plan to do is start this study group somewhere in September. Still have to find a date that does not conflict with any other user groups that we want to attend. And the format is very simple and minimal. So it's of course free, open to all. It doesn't matter if you have experience in functional programming or not. We don't know yet exactly the sort of skill set that is required to follow the study group. We want to see and have an idea of the audience first. So there will always be a short lecture, presentation by some member of the group. Again, we'll probably do the first couple, and then we'll see with other members who is interested in what. And of course, we want really hands-on session with exercises and project, and really focus on that, do some pair programming and learn Elixir together. And to really minimize the organization, it's really a bring your own laptop, bring your own drink, bring your own food. We do not provide any of this. Feel free to come and let's keep things simple and focus on learning a new language. So there is no really any agenda yet. All these topics are part of the Elixir and Erlang ecosystem. There's a lot to cover. Things are moving fast. So pretty obviously the first session will probably be just an introduction to Elixir for people who have really never thought about it or never seen any code. So this is really we're only getting started. We just have a Trello board with nothing that has been done. we just started working on this. Started working on the material for the first lecture, and just get in touch with us, and it's not public yet. We'll just invite you to the Trello and get some feedback. So starts in September. It will be hosted to start with, at least at DevSpace in Wavre. It's 15 minutes from Brussels. This is our co-working space. And at this point, we're really only expecting feedback from you people. Are you interested in Elixir? And we want to have ideas about topics to cover, exercises. And so right now, we're just starting this. It's Xavier, it's me, and Yuri. You probably know him also from the Ruby user group. And so we'll just start. We'll get this thing started, and then we'll see. It's probably going to be a monthly thing, and see where we go there and how we go there. So first one will be just a gentle introduction to Elixir. You're all welcome, and that's all I have today.
Elixir?
Yes, but it's dynamically typed.
Okay.
So
It's not like Haskell where you have like.
no, it's maybe I forgot to say it. It's really down to earth, pragmatic. It's not. It's pretty far from. Let's say even when you look at Clojure, you read the documentation in Clojure, you have to read 3 times the description of the function because it's so like academic. And Elixir is not at all like this. It's very pragmatic. Yes. You can really see the influence of Ruby in that part. And you
Another. Yeah, so quickly, like there was a Phoenix web framework.
Yes.
Is that something that's starting?
It's starting. It's getting. I would highly recommend you to watch the talk from Chris McCord, the author of Phoenix. He gave a talk at ElixirConf. Gives a pretty good idea of where this is going. So I would say 80% of the people at this conference were former or Rubyists looking for a better way to run concurrent software. So they are bringing a lot of influence from Rails, but also people are very self-conscious and they don't want to build a new Rails. They sort of keep things separate. So a Phoenix web framework is really a web framework. It doesn't really have a model layer, but it does things pretty in a very, very interesting way. So it has built-in support for WebSockets. They're working on a new sort of services API. So when you think about what they're doing in Rails now to add this active queue,
Oh yeah, the layer on top of
active,
like
you know, this sort of
delay job.
standard interface to the
Exactly.
asynchronous processing. This is really, first it's already built in the language in the VM, but there what the Phoenix people are doing is pretty interesting. So it's on Conference. I would really highly recommend you check the talk about the web framework, Phoenix web framework. And yeah, and I think it's safe to say that we will probably quickly cover this in the study group once the basics are there. Good stuff.
Any other question?
Thanks.
Thanks a lot.
Application.